Good afternoon, students. Am I audible to everyone? Can anyone give me the confirmation? Is my voice is clear? What, Harsha? I didn't get you. Is my voice is clear?
Clear, sir.
Yeah, thank you. So today I'm going to discuss about this is my third lecture on power systems. So already one more faculty has dealt another class for you. So power system is very vast subject, but the ace of studying this subject is what some of the questions which you are getting. So that requires the basics of other subjects. Like for example, uh, the basic subject which you need to have for learning all the subjects is your electrical circuits, right? So, some of the concepts in mathematics. So, these two will combinedly give you the results of other subjects which are taking the basics of from these subjects without learning those concepts. So, I'm not saying like you should not, there is no need of learning the concept, okay? But I'm saying you should have a common sense. Okay, so how your the common thinking will work out in getting the result. So for that, I'm putting some of the examples today. So which after going through these examples, I'm sure that you can understand that GATE exam can also be qualified by going with the basics and with a common sense. Okay, so let me quickly present the examples. So I'm not presenting any the questions which I have prepared. Why? Because I want to give you the truth. Like I have collected these bits from uh, the previous gate examinations, so that you can understand that by going the basics also we can answer the some of the questions, especially in power systems. Okay. So in machines also you can have the in the same passion. Okay. So this first question. So actually, here I presented two questions. So as a continuation of my previous class, these two questions belongs to continuation of previous class, and then I quickly go to the common bits, which depends upon the very basics of electrical circuits and simple mathematics. Okay. So let me go with this first problem. So left side is first problem, right side is second problem. So first problem, what they are given is the per unit parameters for a 500 MVA machine on its own base are inertia m equals to 20 per unit and reactance x is 2 per unit. The per unit values of inertia and reactance on 100 MVA common base respectively. So what they are giving, so they have given the m value and x value for 500 MVA machine. Now they're asking you what will be the same m values, x values for a 100 MVA machine. So for this, you require the basic relation between MVA and the parameters which they have given. So once if you know the relation, then based on mathematics basics, you can solve this. So I'll explain you the basics of this. So reactance 500 MVA. So as the reactance is one of the parameter which requires more currents. It draws more currents. Okay, it means that capacity is required high as your reactance increases. Okay, so capacity of a machine is nothing but the rating of the machine. So your reactance is directly proportional to your rating of the machine. So I got one relation. Okay, next inertia and then rating. So as I said, the capacity. So as the inertia increases, the capacity itself is utilized for its internal inertia and then remaining will be delivered for the load. So what I mean to say is that as the inertia of the machine increases, okay, the net capacity of the machine decreases. So it means that the inertia is inversely proportional to your rating of the machine. So from the subject, you're going to get only one thing, that is the relation between the parameters. Okay, so now I got the relation between the parameters, that is MVA is directly proportional to your reactance and MVA is inversely proportional to your inertia. Okay, so what it means, for example, take reactance. The old reactance, old MVA. New reactance, new MVA. So, as I said, the proportional, then you need to consider the new by old equals to new by old only when it is directly proportional. Okay. So, similarly for inertia, is inversely proportional. So when you're keeping the ratio as new by old, then this side rating you need to take it as old by new. So that is the basic mathematics. When you got the relation, then it's very easy to arrange uh, the mathematic formula from this relation. So let me show you the result. That is what I said. So your M is inversely proportional to rating. So it means that new by old equal to old by new, inversely relation. Similarly, when I said X is directly proportional to your MBA rating, so new by old equals to new by old. Okay, so that's what I said. You need the basic, very basics of mathematics. Okay, so only thing is from the subject you're getting the relation. That's it. Okay, it's not like a kind of formula. It's just like a basic relation, and then you need to implement it. Okay, so once you know that the inertia new by inertia old equals to old MVA by new MVA, then it's very easy. You're keeping the same values here. Okay. Similarly, here also you're doing the same way. X new by X old equals to MVA new by MVA old. Okay. So this is one example for your mathematics basics. Okay, so where you are relating your subject and your basics. So in the gate, all the questions requires subject with basics. Remember this. When you're preparing your gate, you should have this thing in mind. That's why it is called very difficult. What people think is, yes, I'm learning the subject, I'm practicing the subject, I know all the concepts in subject, but it's the way of thinking is wrong. So you should have a subject, that is the knowledge, the complete knowledge on the subject, along with the basics of your mathematics and subjects. Then only you can give the answer for questions in almost above 50% of the questions. So if you take the very recent gate paper also, you can witness it. Okay. So this is one example which is previously given for 1 mark question. Okay. So this is the best example. So next, the substitution is very simple, right? So if you know the new equals to old into old rating by new rating, so obviously you are substituting the same values and you can get these values. Okay. So next, this is as I told. This is in my last class. I told you the relation between your cost and expenditures. So the same problem. So here they have given the relation. So to your fuel cost characteristics F1 and F2, and then they mentioned that where P1 and P2 are the generation in megawatt of G1, G2 stations. Next, they will give one condition, that is for most economic generation to meet 300 megawatt of load. So they're saying 300 megawatt has to be met. So what is the meaning of this? The load is required 300 megawatt. From where it is coming? From both G1 and G2, generation station 1 and generation station 2. It means that the both powers combinedly delivering 300. It means that P1 plus P2 equal to 300. So now you have one condition and two equations. Okay, as I said, the optimal operation. So we are just doing the first derivative of it and equating both the fuel cost. Okay, as I told you in the previous class. So these two equations, what you're doing, you're doing the first derivative and equate it. You will get one relation. Okay. So first derivative of the equation, when you equate it, BB gets cancelled. Then you have 2C here, here 4C is there. So you will get P1 equal to 2P2. So this is one relation, and another relation, what we discussed, another relation is economic generation to meet 300 means, so two generating stations are supplying 300 megawatt. Okay, that is the way you need to understand this particular line. Okay, so 300 megawatt, P1 plus P2 equal to 300 megawatt. So now again mathematics, as I said. So obviously subject plus your basic mathematics is required. Okay. So P1, by solving this two, you're substituting P in the second equation here, that is P1 is 2P2, here substitute 2P2, you will get 3P2 equal to 300, P2 equal to 300 by 3, P2 is 3, you'll get 100, then substitute P2 in this, 2 into 100 equal to 200 megawatt. So this is how the way you need to prepare all the um, problematic things or your subject things. Okay, so that's why I said you need to have a subject along with mathematics. Okay, so next, yeah, so next, here are two more questions. So little bit, this is the critical one in the last 15 years. So this is a critical one which they have given for 2 marks. Okay, the same way, like how you solved this one. This is a direct one. Okay, fuel cost they will give you. You're doing the first derivative with the power and equating them for getting the relation between the two generation stations. Then they will give you one more generation relation between the two generation station power delivery. So likewise, you are getting this answer. This is a more difficult one. Okay. With this, all the models will be covered in this particular area. So here, if you observe, they have given three generating stations. That is fuel cost. It means that three costs means three stations. Okay. So the cost one, they are given 20 plus 0, 0.3 P1. So second cost equals to 30 plus zero point 0.4 P2. Third cost equal to 30. So all the that is power is in megawatt. Like totally three stations are there. And what other conditions they have given? Assume that all the three units are operating all the time. All the three are operating. They're saying all the time, all the three are operating. Okay. Next, minimum and maximum loads on each unit are 50 megawatt and 30 megawatt respectively. So they mentioned they have not given, now this time they are not giving what is the load on each station. They are saying, so what is its minimum value, what is its maximum value for all the three stations. Okay, if the plant is operating on economic load dispatch, so operating in economic load, economic, when you see this economic word, so it means that, so the first derivative of any two stations you can equate and get the condition. Okay, so that is a key point you need to remember to supply the next the continuation. What they are given, if the plant is operating on economic load dispatch to supply the total power demand of 700 megawatt, the power generated by each unit is, so what they have given here, they have given three things totally. One is incremental cost of individual stations. Next, the power minimum and maximum power generations by all the three stations. After that, they have given what is the total load. Total load is 700 megawatt. Total load is 700 megawatt. So it means that P1 plus P2 plus P3 equal to 700 megawatt. Okay. The power generated by each unit is. Now we need to calculate three powers. Okay. So here, when you see the what to find, so we need to find three powers P1, P2, P3. It means that we have totally three variables. We require three relations. In this previous problem, if you see here you need to find out only two variables, P1 and P2. So that's why you are searching for only two relations. One relation is total power, that is P1 plus P2. One relation is P1 plus P2 equal to 300 megawatt. And second relation, we are using the economic load dispatch. That is, first derivative of this equals to second derivative of this. So similarly here also, we need totally three relations. So one relation is already known, that is P1 plus P2 plus P3 equal to 700 megawatt. And second relation somehow we are getting by doing economic dispatch, that is dou IC1 by dou P1 equal to dou IC2 by dou P2. We can write that. Okay. Now, uh, what we can do for finding the third power. Okay. So here there is no other clue. There is no other clue when you read all these things. But if you keenly observe this, they have mentioned one point, that is the minimum and maximum loads on each unit are 50 megawatt and 300 megawatt. Okay. So here they have 300 megawatt. So now, uh, by using this condition, we need to find out the third relation. So what is the third relation means, either they have to give some certain relation or they have to mention some powers are adding up and then causing the third power like that. Here they have not mentioned any kind of such things. So in such type of problems, you have to go with certain assumptions. Obviously, by seeing this, you need to go for certain assumptions. So here, if you observe the incremental cost, so for IC3, they have not mentioned the P, it is not depending on P3. So it means that it is completely running at maximum. It is completely running at maximum. So this thing you have to observe very clearly. Okay. So here incremental costs are depending on each and every power. It means that they are operating between the minimum and maximum. But here it is constant. Constant means it is working with full load delivery. So what is the maximum load they mentioned? The each station, it might be minimum 50 or maximum 300. So obviously the third power will be your 300 megawatt. So now we got one value, P3 equal to 300 megawatt. From this we can eliminate C and D. Okay, so the concept is called odd one out. So always you need to remember, if you don't know the answer also, so you need to use the common sense, which is called odd one out for the given question. So which might be the answer without going through the actual concept. This is the way some of the people will answer the question correctly. So they will remove the odd one. Odd one means the wrong one they will remove. So now we got the clarification that the last power is 300 megawatt. So P3 equal to 300 megawatt only we have in option A and B. So C and D are wrong answers. So now we need to find out which one is correct, either A or B. So now the same process as I said. So you have to go with the two relations, that is P1 plus P2 plus P3 equal to 700 megawatt, P3 equal to 300 megawatt. So by substituting 300 megawatt in that, you'll get P1 plus P2 equal to 700 minus 300, totally 400 megawatt. We got one equation, P1 plus P2 equal to 400 megawatt. And next, dou IC1 by dou P1 equal to dou IC2 by dou P2. With this, you will get another P1 P2 relation. Then by solving those two, you will get P1 P2. So here is the solution for it. Okay. So here they are equating this incremental cost. Okay, either by derivating or by equating directly. Okay, there are two ways you can do in any manner. Okay, so if you have otherwise you just remember when compared to the previous one. So here p1 square you have a second degree equation. Compulsory you have to you have to do the single time derivation. Okay, so when you have only the power the order as 1, okay, degree as 1, no need to derive directly, you can equate it. It's already the they have given the direct incremental cost. Okay, so it's a fuel cost and it is a incremental cost. It's a fuel cost and this one is a incremental cost. So as I said, P3 you need to consider as a 300 megawatt maximum because based upon the incremental cost which they have given, we have assumed like that. And second condition is economical dispatch, that is both incremental costs are equal. And then as I told, P3 equal to 300 megawatt, you're getting P1 plus P2 relation, and then later one more relation from this. So this is another relation. So you have to solve this equation and this equation. So what here they have done is they substituted P2 equal to 400 minus P1 in this first equation. Okay, P2 equal to 400 minus P1 in the first equation and they calculated P1. Okay, once if you got the P1, then it is very easy to find out the P2. Okay, and one more thing. What some of the people will do is, I got the P1 and I know the P3, immediately they will select the answer. So never do such kind of things. In GATE, you have to solve the problem till the end. Why? Because this, see, P1 242.8. So you might be having the same answer as P1 equal to P1 equal to and P3 equal to 300. Okay, not this problem. So usually in GATE, when you're solving the middle by choosing this middle answer immediately, so some people what they will think is they'll think like I need to save the time. So quickly I got the one two answers. So with this I'll directly choosing the option. So you should never do like that. So solve the problem completely, then you choose the option, because wherever you will do the mistake, that mistake answer is also available in your options. So that is the way how they will prepare the gate paper. Okay, so this is the highest level of problem in this particular area. Okay, so with this, I'm closing this particular concept, incremental cost concept, and previous problems. So now we will discuss, as I said, you should have the basics of our subject and then the common sense, very basic, very basic principles, knowledge. So, for example, take this problem. Okay, here what they are given, a 50 hertz three phase alternator has an inductance per phase of 2 millihenry. Next, its neutral is grounded. It feeds a line through a circuit breaker. The total stray capacitance to ground of the alternator and circuit breaker is 0.0025 microfarad. A fault occurs just beyond the circuit breaker, which opens when the symmetrical sheet circuit current is 7500 amperes. Ignore the first pole to clear factor. The neutral frequency of oscillator will be. So, if you read all this complete data, you will get more confusion. Why? Because they are saying there is a alternator and then you have a circuit breaker. So, the purpose of the circuit breaker is to protect the alternator. So it will trip it. Okay, whenever there is a fault, immediately it will trip it, and then it won't allow the high currents into your machine. In such way, it is going to protect the winding of the machine. Okay, so it's one system, arranged system. In this arranged system, they are giving some parameters like what is the supply. It's a three phase supply, 50 hertz frequency, and they are giving machine inductance 2 millihenry. After that, they are mentioning what is the capacitance, stray capacitance from the alternator to circuit breaker between this arrangement. So it means that now you have the inductance and capacitance from circuit breaker to your alternator. Okay, so you have these two. Now they mentioned one current also. Okay, that is symmetrical circuit current. Now they're asking the neutral frequency, okay, of oscillator. So if you read all these things, inductance, capacitance, frequency, and current, four quantities are available. And I need to find out the frequency, natural frequency or resonating frequency. Okay, so natural frequency we need to calculate. So now, is there any relation between the frequency and among these four quantities? If you think like this, then you can answer this. Otherwise, you will be in a loop. You in your mind you will always think, current is there. They have given current. Is there any necessity of this current? Because of this current, any dependency of the natural frequency. So you will be always thinking about it, and it may take 10 minutes or 15 minutes also. Okay, so don't do that. Blindly go with this. Like, what is natural frequency? So frequency, for finding the frequency, what are the formulas we have? So for finding the frequency in terms of inductance, capacitance, we have only 1 by 2 pi root LC. That is one formula we have. Is there any other formula for finding the frequency we have? Yes, of course, we have other formulas also for finding the frequency. In your parallel circuit, we have a different frequency. Then the question rises, which formula I need to use? Now I got 2 3 formulas for frequency, and then now again I stuck up with which formula I need to select. So you need to think like this. For a particular formula, we require what parameters? The formula which I told you, F equals to 1 by 2 pi root LC. In that, we require only two parameters, that is inductance and capacitance. And in other formulas, what are the parameters we require? You just cross check it. Okay, so with this comparison, you will conclude one formula which exactly fit into this formula. So here we have your inductance and capacitance. The simple formula is F equals to 1 by 2 pi root LC. This is a 2 marks question. See, F equal to your 1 by 2 pi root LC. This is the answer for this. Okay, so why I kept this question is, this question will waste your time by reading the question, by understanding the question, everything. Okay, so what I suggest is that you just go through what you need to calculate and what parameters you got, that's it. Even though this formula is related to your electrical circuits, actually by seeing all these parameters, what you will think? Circuit breaker is there. Circuit breaker means immediately you will think that this is a power system question. There is no question. There is no other thought. Some people will think like alternator is there, then this belongs to a machine's subject. So you will be in this loop only. You're searching in power systems in your brain, like what formula is there for this. You're searching in machines also because alternator is there. Is there any formula for this? You're forgetting about the very basic subject, that is your circuits, where the finding of the frequency, natural frequency, the formula is 1 by 2 pi root LC. Okay, so that's what I am saying. For some of the problems, there is no need to think much of your what data they have given. Okay, they will give you very big data, like for reading purpose. They want to waste your time by reading. That is their motto. Okay, so that's why you need to go with your very basics of electrical circuits. So then, if you think like this, then you can easily answer and you can get 2 marks for this. Okay, so let me take up two more problems. Okay, in the same power systems. Actually, these two are power systems only. But the answer you are getting with the help of your circuits. Okay, that is the magic kind of thing. What I'm saying is like some of the problems in your machines or power systems you can answer with your electrical circuits and some basic mathematics. That is advantage of power systems. Okay, and electrical circuits. So let me read this for you. That is a 240 volt single phase AC source is connected to a load with an impedance of 10 at an angle of 60 ohm. A capacitor is connected in parallel with the load. If the capacitor supplies 1250 reactive volt amperes, the real power supplied by the source is. So they mention some parameters. So actually this is a power systems. Okay. So what they are given? The supply voltage single phase supply they are given 250 volts. Next, what is the impedance they have given? They are given Z equals to 10 at an angle of 60. Later you can convert this into your rectangular format also using calculator. A capacitor is connected in parallel with the load. Okay, if the capacitor supplies a volt amperes, it means that VAR is, so it is supplying a VAR. So what it is? VAR is the unit of your reactive power. So you need to understand what is this value. So always don't go with your data which they are given. So you have to go with the units what they have given. So VAR is the unit for your reactive power Q. Now they are asking real power P. So how to get your real power when you know your reactive power? Is there any relation between P and Q? Can anyone tell me what is the relation between P and Q? If you search in power systems, you won't get this idea. You have to go with your electrical circuit basics. So the basic power definition, we have three types of powers. What are they? I'm damn sure that you remember the power, this power triangle and impedance triangle. One mark you will get from this power triangle and your impedance triangle. So can anybody tell me what is this power triangle and your tell me what is the power triangle and impedance triangle? So what is power triangle and what is impedance triangle? What is S? What is S? Okay, I'm helping you. So now tell me at least from your end. What is S equals to P plus JQ? Can anyone explain this? Okay. So S is apparent power, P is real power, Q is reactive power. So just remember my words. If you know this power triangle and then impedance triangle. What is impedance triangle? Z equals to R plus J X. So yeah, J represents imaginary term. Okay. So it's very simple. So your power triangle or impedance triangle you can remember by comparison. Okay. So adjacent side you will be having real power term, and opposite side you have reactive power term. So P R. You have to learn these two side by side to understand many things. If you learn these side by side, then we can have the answer. So remember this: the net impedance is nothing but apparent power. Okay, so real power, when you have a load as R, if your load is purely resistive, it means that it requires only real power. So your power factor is unity. So when you have reactance, it will require reactive power, and your uh, power factor is a non-unity quantity. Okay, so that's why if you X exists for any device, obviously it requires Q. Okay, Q component. Really, if you have R value more, then it means that real power is more. Okay, when you have real power more, your power factor is more, losses will be less. So you have to remember this. It's very important. So 1 mark you can, 1 or 2 marks you can gain by remembering only these two. I'm sure. Okay, about this. So now I need real power. I need real power P. What they have given? They have given Q. Capacitance. You have a capacitive reactance X. So for that they have given VAR. It means that they have not given X value. So here you need to understand this point. If the capacitor supplies means they are giving, for capacitor they are giving a reactive power delivery. Capacitor delivers reactive power, inductor consumes reactive power. Okay, so that point you need to remember. So now I need real power. So if I know Q and I need to find out P, then what value I require? I require S. Okay, it means that I need to find out the net apparent power S equals to your V into I. Okay, or you have other formulas also to find out your S value, total power, apparent power, S equals to VI. Or if you have only V and impedance, so what is the data they are given? They are given your voltage and impedance only. I don't have a current. So now what is the formula? So generally your apparent power you can write as V into I, or V square by Z, or I square Z. So these are the ways to find out your apparent power. Okay, so now here we have V value and Z value. So which formula I need to use for finding the power, apparent power? S equals to V square by Z. Okay, V square by Z. So with that you're calculating S value, and then you can easily get your real power term also. Okay, from the apparent power you can directly get that value also, and you need to use this formula. S equals, you will get here, you will get all the quantities in either in polar form or rectangular form, but I need the value of the power and reactive power. They have given reactive power Q value. I need P value only. When you write your apparent power in complex form, P plus JQ, then only I will be able to write my P separately. So whatever is apparent power you're calculating, you will get either in polar form or directly your rectangular form. If you get in rectangular form, then you can get that real power easily. So here is a solution for it. So see this. So here what they are giving is you have 250 to 40 volt supply, right? And then there is an impedance. How it is connected? Single phase AC source is connected to the load with an impedance of 10 at an angle of 60 ohms. So source is connected to a load directly. your source is connected to a load directly, and a capacitor is connected in parallel with the load. It means that the source impedance and sorry, this itself is a load, source, load, and capacitor. All the three are in parallel. All these three quantities are in parallel. Okay, so capacitor is delivering to the load. Source is also delivering to the load. So now in load, two currents will be combining. Okay, so source current plus capacitor current. So source current plus capacitor current. So the total current is I plus IC. So now this is the I plus IC. I refers to the current in this loop. Okay, in this loop, total voltage is 240. Total impedance is only Z. Okay, then I equals to V by Z. Directly you are writing I equal to V by Z. Next, IC. This is also V by Z. So here, the formula we need to derive it from the power, because here they have not given impedance. If they give you impedance, you are writing V by Z. Here we can't write this as V by Z. Okay, so then how to write here the current from this capacitor? So what power you got here? You got your Q. Then what is the relation between Q and I? So you need to go with the relation between Q and I, and you have a voltage. Voltage is parallel. So here also 240, here also you have 240. So what are the quantities you have? Current, voltage, and Q. What is the relation between your Q, current, voltage? So Q means is nothing but a power. Okay, so then how you are getting your current? So actually Q equals to VI. So V means supply voltage, I means IC, but I need IC. So you're getting Q by V. So Q by V. Q is 1250 by V. V is 240. So Q is 1250 by 240. So here you should be very careful whether they have given kVA or VAR. If they give you kVAR, you need to write into 10 power 3. Okay, you should be very careful for this. It's a very simple problem, but we'll do generally mistake with K. By assuming K, you are going to derive the answer. The same answer will be there in the option. That is how they will prepare the options. Okay, so that's why you should be very careful. So I think you got how these two have been written. So I is V by Z, IC is it's a JQ, right? So it's an imaginary term. Q is always imaginary term, J into Q. That's why they have mentioned J into imaginary term, imaginary current part. So you have voltage, current, VR, then Q equals to V into IC, IC equals to Q by V. This is how you're getting your currents. This is the total current through the load. We calculated current through the load. So now we know the formula S equals to V into I equals to P plus JQ, right? So obviously from this, you can get the value of your real power. Okay, so what is V into I? So you have the V value, and I value is this 12 minus 15.60 into J. So here P plus JQ, we are not substituting anything in this P plus JQ. We are calculating only VI. This is V into I value. We got total current I. So V into I. So we got V into I as like this. Compare this term with this P plus JQ. That is, compare real part and compare imaginary part. If you compare real part, P equals to 2880, and the reactive power supplied is 3744 J minus 3744 VAR. So from this, real power equals to P equal to 2880. So this is how you need to use your electric circuits basics in your power systems. Okay, this is a 2 marks question. Similarly, we have one more 2 marks question in 2004. They have given. Uh, yeah, uh, a 800 kilowatt transmission line is having per phase line inductance of 1.1 millihenry per kilometer and per phase line capacitance of 11.68 nanofarad per kilometer. Full stop. Ignoring the length of the line, its ideal power transfer capability in megawatt is. So this seems transmission lines. Transmission lines is a part of your power systems. So we will think like it is in power system. I don't know that. I have not read the power transmission lines concept. So I'm going to skip this bit. So it's not like that. So at least give a try. So damn sure you will be able to answer because while I'm attempting the gate twice, I cleared the gate because of only this basic principles. I prepared only electrical circuits, control systems, and mathematics. That's it. Okay. So I applied the same techniques. Within a short period, I qualified because of only this way of thinking. Okay. So a 800 kV, it means that they have given voltage and then they have given inductance Z, capacitance C. Now they are asking power P. Okay, so now we need to again go with the power, inductance, capacitance, voltage. So power is always V into I. So I don't have a I value. I don't have, yes, V is there, 800 kV. Okay, voltage is there, current is not there. It means that I cannot use V into I formula. Then is there any other formula in terms of voltage can I find the power? Yes, of course we have. So for power you have Vi or V square by Z or I square Z. There are three ways of calculating your real power, megawatt. They asked megawatt, not mega VAR. Remember this. VAR means reactive power. Watts means real power. So you have to go with the units. Okay. If you are unable to understand the problem, at least go with the units. Okay, we need to find out real power. Real power means obviously V into I or I square into Z or V square by Z is the formula for real power. Okay, so V into I have V but I don't have I cannot use this formula. Next, I square Z, same thing. Current is not there, so I cannot use this. I have another formula V square by Z. So V is there. How I can calculate Z for transmission line? So the transmission line voltage is there. If you calculate transmission line uh, impedance, then it is very easy to calculate your power. So transmission line, you have studied in your two-port parameters where the characteristic impedance, so ABCD parameters are used for transmission lines. So there you have studied the characteristic impedance, means impedance of the line. Okay, so that is ZC equals to square root of L by C. So you have L and C values. When you see L and C value, and if you want to find out the Z, there is only one formula. There are two formulas, that is Z equals to R plus JX. So here R is not there. So it means that you cannot find out impedance using R plus JXC formula. So other way is only through characteristic impedance formula, that is ZC equals to square root of L by C. Okay, so L is there, C is there. So simple, very simple. Z equals to square root of L by C, and then you're calculating the ZC value. After that, I need power. Power equals to V square by Z. V is 800 whole square by your Z value. So just check out this. Same thing. Your impedance. So we will call it as with the different names in the subjects, but the formula remains same. ZC equal to square root of L by C, and then P equals to V square by Z. Simple. See, if you see the answer, you will think like how big, how big I foolished by this problem. So by reading this, you will think like it is a transmission line they have given per kilometer. You will get so many confusions. But if you think with the basics of electrical circuits, damn sure out of 6 to 7 power system questions, 2 questions you can answer very easily with the basics of electrical circuits. Okay, so this is how we have to prepare for the gate to easily qualify. Okay, so that's why I used to say like when you're preparing a subject, have very basics. You should be very strong in the basics. So once if you are very strong in the basics, obviously based upon the units, you will decide the relation between the terms, and then you can answer it. Okay, so that's all for today. Okay, uh, tomorrow we will discuss some more topics. Okay, in the same way, the basics and then your power systems. See, remember one thing: as we have less classes, we cannot cover all the topics. We can cover the what is what, the main theme of the point. But damn sure, if you follow our classes, you can easily clear the gate examination. Okay, so that's what I'm saying. So for getting a good rank, you should practice more. Okay, for clearing the gate, so whatever we are sharing, if you follow the same principles and the way of answering, so damn sure you will clear the gate examination. Okay, so thank you for attending the session. If you have any queries, I'll be waiting for 2 more minutes, so you can ask me. Otherwise, after 2 minutes, I'll be closing the session. Okay, so thanks for attending the session.